I would like to introduce you to Cameron Wood from Container Solutions, the head of CRE department, right? And then we have Pavlo Baron from Instana. He is their CTO. Hello guys, welcome and thank you very much for joining. And I will leave it with you, Cameron.
Excellent, thanks, Teresa. Just let me start sharing my screen and we'll get started. All right, let's get started then. Thank you for joining me today. Here are the topics that I'll be covering today during the presentation. As Teresa already mentioned, we'll take question and answers at the end of the presentation. So please note down somewhere any questions you have or post them in the chat as we go along and we can go through them after the presentations. Just a quick bit about me. I'm Cameron, the head of Customer Reliability Engineering at Container Solutions. Prior to joining Container Solutions, I had been working in the systems engineering and SRE space for over 7 years. If you'd like to follow me, read up some more on my background, or just get in touch, here are my relevant online handles, as well as my email. Quick bit about Container Solutions. We're a professional services firm that specializes in cloud-native computing. We draw upon a wide range of skills and experience honed in the real world. We pride ourselves on helping customers adopt cloud native. We bring culture, strategy, and technology together to make sure your cloud native transformation is done right. We're based in Amsterdam, Berlin, London, Montreal, Prague, Warsaw, and Zurich. And we're also one of only a handful of companies in the world that are a Kubernetes training partner, a Linux Foundation authorized training partner, and a Kubernetes certified service provider. So what is Customer Reliability Engineering, or CRE? We created CRE to address the growing needs of our customers. It leverages our experience in helping customers become cloud native, along with the insights we've gained observing the common challenges of running applications in production. It's modeled after the SRE principles from Google, but adapted to suit the needs of our customers and CS alike in terms of delivery. We use the production readiness review to assess the readiness of a team or service to become a CRE customer. And this gives us a signal of their maturity and capabilities and gives them an honest review of their state, both in terms of technology and culture. So, starting an SRE team, where to start? The image on the left is Dickerson's hierarchy of service reliability, but with one small change. I've added an extra layer at the bottom to address team building. This is actually a great reference model to use for how to approach adopting the SRE practices in your team. Like building a house, it's important to build on a strong foundation. And that's why it's important to build your capabilities up layer by layer, only moving up to the next layer when you're confident that you've gained at least an intermediate level of competency with the previous layer. And this is also why we've taken upon ourselves to add this explicit layer for team building, because it needs to be explicitly thought about and shouldn't be overlooked. You can't just assemble a team and expect them to perform well together without some deliberate effort and steps to encourage and hone that. Even if you've already started adopting SRE, if you're experiencing any issues along the way, you can use this model to go through the layers and help you reason about these competencies and rectify any issues you identify along the way. Keeping in mind that if you find a problem at a lower level, then be suspicious of the layers above. You want to have a look through them and make sure that there aren't any other issues lurking in there. Given the time that we have today, I'll only be going through the first 5 layers of this model though. So, building your team. Whether you're building your team from scratch or have already assembled a team, thinking about the qualities you want those people to exhibit is important. Is experience working in an SRE team already critical, or is curiosity, enthusiasm, problem-solving skills, or experience in a related field just as important? Culture and values can play an important part in helping to drive the behaviors that you need to have a successful team. For example, pragmatism, accountability, empathy, craftsmanship, honesty, and tolerance, to name just a few. And purpose is another important thing to think about and can be crucial to providing the team with the right intrinsic motivation and perspective of what they're working towards. In my team, for instance, we use a combination of values, culture, our mission statement, and objectives and key results to motivate and guide our work. Tuckman's stages of group development, which is the image to the right here, is an invaluable concept to understand if you're trying to create a high-performing team. Understanding these stages of group development and recognizing where your team is on their journey is crucial to fostering the right habits and outcomes to continue making progress as a team. Also, understanding that your team can and likely will regress to earlier stages at times is important. And being able to recognize this will help you deal with this and ultimately help your team more. Also, will this be a remote or physically located team? Obviously, in our current situation, this is more valid a question than ever, and recognizing the challenges and advantages of a remote team or a physically located one is important, especially with regards to a remote team in the stages of team development, but also with regards to a team culture and values alike. So how would you encourage collaboration and socializing that previously took place in the office with digital equivalents in a remote first world? How do you onboard new remote first team members and still give them the same quality of experience as the previous physical onboarding experience provided? These are all important considerations to have answers to, depending on your situation. So, monitoring. What's that, Houston? We have a problem? Sorry, I couldn't resist with this cheesy line. But keep it simple. Only take what you need. Leave the kitchen sink at home. You probably aren't NASA, and everything has a cost of some kind, whether it be money, operational burden, the complexity, time investment, or something else. So treat it like a minimum viable product, an MVP. What is the smallest set of features you need to get started? Would monitoring, logging, and alerting be enough? Do you build your own, or can you leverage a software as a service, SaaS solution, like Instana or similar? When thinking about whether to host it yourself or use a SaaS solution, one very important consideration is your data retention needs. So how long do you need to keep your data? And how will this affect your costs? And if you're self-hosting, what applications will this have in terms of operational overheads? And thinking about how the data needs of these systems will likely grow. Will they scale linearly or non-linearly over time? And what will this mean for you in terms of management overhead or costs for that extra data, even if you are hosting it or using a SaaS solution alike? Will hosting it yourself mean having to shard your data at some point? And if so, knowing upfront when that might be, and knowing how much data each host produces and what host count you're likely to hit some scaling point at is a useful horizon to know about and watch. Similarly, what information privacy regulations do you need to consider? Are you working in a regulated industry or doing business across multiple jurisdictions? Does GDPR or HIPAA or something like this possibly apply to your company? Like the old adage goes, you don't know what you don't know until you start measuring. And you don't know what kinds of data are hiding in your systems until you really go digging to find out for yourself. These are often overlooked aspects of building a monitoring and observability capability. For instance, what backup and disaster recovery capabilities will you need if you decide to build your own solution? And what would your recovery point and time objectives look like? Most importantly though, thinking about these questions up front can be a useful lens for testing assumptions. Possibly you don't have as high a data retention requirements as you first thought. Important thing though is these are all just suggestions and food for thought. Don't succumb to analysis paralysis or end up evaluating and designing things to no end. Remember, it's just an MVP to get you started. Make some trade-offs, test your assumptions, then get some feedback and start iterating from there as needed. So, incident response. You have to build your own incident response framework. Just like adopting SRE, these are just principles and some guidelines. You have to find what works for you, your company, your customers, your situation. If you're a company working in a single jurisdiction, it'll be very different to a company working in a regulated industry or a multinational company, for example. So tailoring your incident response frameworks to your needs is crucial. An incident priority matrix is there to help you translate impact and urgency into a priority, which is an invaluable tool to help you classify your incidents correctly and reason about these properties. One thing to be aware of is that impact and severity are essentially the same thing, but I recommend using the term impact. This is because severity is often confused with priority, which is because these terms have been used interchangeably over the years to classify alert levels. Think back to when you might have read or heard the term SEV1 incident before. They aren't the same thing though. So separating them and avoiding this somewhat often confused or misused term is a good idea. So I recommend you would stick with impact, urgency, and priority. You'll thank me later, I think. And alerting principles, like the golden rule that if an alert isn't actionable, then it shouldn't be an alert. A great example of this is informational alerts that don't actually indicate something's broken or about to be broken. This is an anti-pattern and something to avoid. Or alerts that are handled by some automated tooling, whether that be Kubernetes, an auto-scaling group, a hook to a monitoring agent, or whatever. If a human doesn't have to take action, then it shouldn't be an alert. And always provide context in your alerts, whether that be the alert title itself, or the body with a link to a relevant monitoring system, or perhaps a link to a runbook for a known condition, which can't be automated away. These are all applicable. When it comes to incident roles and responsibilities, do you have incident commanders or incident managers? Depending on your interpretation, you might think those are the same thing, or you might be completely distinct roles. What about scribes, subject matter experts, deputies, or communication officers? And what other roles might you need depending on your situation? When do you bring in a dedicated incident manager to oversee many responders? Or if you have another alert come in for an unrelated problem, for instance. These are important things to plan for and have a clear and concise answer to.
That way, your responders aren't wasting any additional mental cycles. There's less room for confusion or mishandling. And most importantly, your responders are free to do their job and respond to the incident as best they can. So, post-mortems and root cause analysis. So building on top of the culture you've worked hard to foster thus far, thinking about our hierarchy of reliability, establishing blameless post-mortems is crucial to effectively learning from failure and driving improvements. Without a blameless approach, your team will be too concerned with defending themselves or not open and honest enough to help surface the real account of what happens when you do experience outages. Thus, you'll miss out on the actual learnings that were there to be learned and possibly face this issue again because you couldn't identify it the first time. Having a culture of assuming good intentions, open and honest feedback, and psychological safety is crucial to adopting blameless postmortems. Without these foundations, it's not going to be possible to have the open and honest discussions required. John Allspore wrote an excellent piece about blameless postmortems on Etsy's Coders Craft blog, which I highly recommend you look up and read if you're interested in that. It discusses some interesting theories from social psychology, which can help you understand and appreciate blameless postmortems more. Some examples are the bad apple theory, the hindsight bias, fundamental attribution error, and to name just a few. And then we have the 5 whys method, which is a simple but effective questioning technique for drilling down to see whether you have fully explored a problem or whether you are still missing some information or knowledge about it. It's understanding it. This can be an invaluable tool to use when doing postmortems and investigating other issues you might encounter. Being such a simple technique, its usefulness will really depend on the delivery and the situation, or the context. But give it a try next time you dig into a problem. Take some notes and reflect on how it worked and how it was delivered. Don't give up after your first attempt. Iterate. Try and improve the delivery and use. But ultimately, if it isn't working for you, well then don't force it either. It's just another tool in your toolbox. You can find something else that will work better. So why contributing factors instead of root cause? Well, because by this stage of the game, root cause, although often used, is actually a bit of a misleading term. In this age of ever more complex distributed systems, it's less and less common for a problem to have a single root cause. Instead, it's more and more common that there are a number of contributing factors, and you sometimes might not even be able to identify all of them. The point here is that framing the question this way gives you a better lens from which to look for clues, instead of being fixated on a smoking gun that possibly doesn't exist. What do you do with your postmortems? Do you store them somewhere safe? That was a trick question, of course you do. Keep a searchable archive of your postmortems so you can refer back to them and compare the results over time. This can be useful for identifying recurring issues, finding similarities, or other non-obvious trends that might exist between incidents. This can also serve as a valuable source of ideas and inputs for coming up with fire drill scenarios and/or inspiration for game days and chaos tests, which we'll discuss next. For the same reason that professional athletes train and practice, it's also important that SREs train and practice. One of the best training tools in our arsenal are fire drills, which can be an invaluable tool to help with preparedness. Instead of waiting for a real incident to respond to, create fictional incidents and role-play the response. You can use real tooling, real systems, real procedures, all with the comfort of knowing it's just a game. And although the incidents are fictional,
the scenarios don't have to be. You can always incorporate information from past real-world incidents into your scenarios to give them more realism. The important thing to think about when creating your scenarios is what you're trying to test. What are you preparing for? Are you testing tooling and communication, or procedures and response, or something else entirely? Fire drills are also a no-brainer for orientating new joiners to an SRE team and a natural precursor to going on call for the first time. And then we have game days, which are the next logical step, and are often confused with chaos engineering or chaos testing, which, although related, aren't exactly the same thing. Game days are where you create some real-world scenario failure in your system to test a hypothesis about how the system will handle the condition, but also how the team responsible for that system will respond. How do their processes and procedures hold up in the face of this event? You should know beforehand exactly what the plan is, what you expect to happen, then execute it and observe if there's any difference between the two. If the plan doesn't go as expected, why was this? Is your understanding of the system incorrect, or is the system misconfigured, or is there something else going on? And chaos engineering is essentially an automated, scaled down version of a game day. Although the faults are typically smaller in scale and obviously quite more specific, but their timing is random, and hence they are chaotic and hopefully unpredictable. They can be a good option for continually exercising the resiliency of a system after you've used game days to manually verify the behavior already, and are obviously a great way to catch regressions to a system's resilience in an automated fashion. There's nothing like having a self-inflicted outage to bring it to your attention that you've allowed your resiliency to regress. And then we have runbooks, which are operational guides for performing some task in a repeatable manner, whether that be responding to an alert or performing some periodic tasks that can't be automated or happen so infrequently that automating them doesn't make sense. And fire drills and game days are both great resources for testing your runbooks and for identifying any gaps or missing areas. So, time to wrap up. Key takeaways. So, start with your team. It's the foundation for everything. If you don't get your team performing well, if you're not learning from your experiences and collaborating together well, you're not going to be able to execute on this complex, interdependent hierarchy of disciplines that you need for SRE. Forget the kitchen sink. Keep things lean. Only take what you need. Remember, start with the MVP and iterate. Practice, practice, practice. Don't wait until it's game day to try and test your capabilities for the first time. Leverage fire drills, practice game days, do some chaos testing, and then build up your capabilities. Remember, all of this is just suggestions and advice. Find what works for you. Build up your capabilities using this model, layer by layer. Rome wasn't built in a day, so you'll have to face some adversities. Stick with it and give it some time. You'll get there eventually. So just quickly, your feedback is super important to us. We'd love to get your feedback about today's events. I'm sure we'll circulate this link again, but here it is early on as well. Whether or not you found it useful or you have suggestions, it's all useful feedback and important to us. The feedback is all anonymous and obviously only used for improving these events. So please visit the link below if you have some feedback and time to share it with us. And also need to mention that we have 2 more upcoming events that you might be interested in. The first one is around strategy on resilient leadership with our CEO, Jamie Dobson. That's later this month on September 30th. You can get more details on our website at the link below on the left. The second event is the next Software Circus, which looks really interesting. It has a Halloween theme this time, so it'll be exciting to see what cool costumes and characters people come dressed up as. That one's next month on the 29th, and you can head to softwarecircus.io to register for that one. So that's all for me for now. I seem to be right on time, I hope, so that we've incorporated our feedback time after Pavlo's talk following this. So ignore my point about the questions for now, and I will stop presenting so Pavlo can give his talk.
Thank you, Cameron. There was one request, if you can please put a link to the book that you mentioned during your
Post.
talk.
Yeah.
Perfect. And now over to you, Pavlo.
All right. Thank you very much. Thanks for having me. Thank you, Cameron, for this very good introduction to the topic. And so let me first introduce myself. Pavlo Baron, I'm founder and CTO of a company called Instana. And what we do is we provide kind of a very specific approach and tool to observability / application performance management / monitoring. These are all disciplines that are historically very close together. There is different approaches, and I want to focus on one, which is of course very important, and Cameron has mentioned this quite a few times in his talk, and it is generally observability. Don't be scared by the title that has the word enterprise in there. Even if you're not working in the enterprise, at some point when you realize that you need to apply, let's say the SRE methodology and way of work, it means that there is a size and a scale behind that. You just probably don't do this just when you have like 3-4 people in the company. So when there is a size, it comes with a cost. And I will do my best to walk you through how I think, what are the challenges in this modern IT world, specifically when you try to apply approaches like observability, and how to effectively apply them in your organization. That also plays very well together with what Cameron named the MVP for observability, root cause analysis, etc. So let's first quickly look at the changes for the modern enterprise IT. I mean, 30 years ago, yes, I'm that old. 30 years ago, things didn't move, right? I mean, first of all, every single company right now is either forced or is, internally, intrinsically forced to apply the startup way of thinking. You see this all over the place. Any kind of classic big enterprise has a whole set of little garages to establish something new, something specific, something modern, in order to probably accelerate time to market, in order to check out the new directions, etc., etc. There's a whole bunch of motivations behind that. But of course, you just don't call it a garage. You need to think and work as a garage. This is a change in every enterprise IT or in every reasonably sized IT that we see. Another change that has happened to many businesses is that right now you have to compete with everybody. I mean, there is so much disruption going on in every single business that it is pretty much clear that, I'm not really an overall world business expert, but I would claim that there is not a single business left that is free of competition. And the competition is just, it can be small size disruptive companies that just, do little cuts and cut here, cut there, and they claim a piece of your market share, etc. And this is new to the companies that are not really used to move fast, right? The other aspect is, I remember the days where the enterprise IT could really make a prescription in regards to what kind of devices and hardware systems whatsoever people would be using. I think this changes dramatically. If you have a new iPhone coming out once a year, it's pretty hard to sustain the strategy of providing them a 10 years old device that is not an iPhone, since they are used to do it. So effectively what happens is that you get pushed into a technical drive, into a technical modernization all the time. And this comes not from your own organization. It is pushed into you by somebody else. This is also new, so you're driven instead of driving. All that also comes with a whole set of challenges, not only changes. So one thing is a reasonably large IT organization has already accumulated a whole bunch of different systems. I mean, I've seen enterprise architecture wallpapers that could be wrapped around a pretty big room, around the walls, like multiple times. And I've actually seen rooms like that in my past. And then you look for the system like, oh yeah, it's somewhere there. There is a dot. By the way, this has changed 10 years ago, but nobody updated this thing. So the problem that comes new is that the whole tech world has dramatically changed. I mean, the speed of creation and sub-creation of frameworks of different technologies and different kinds of and flavors of technologies, and it's just absolutely rapid. So this variety, effectively, every IT organization has a big problem establishing one single standard, for example, for programming languages, because there's so much coming from different directions. So, and you also want to keep people entertained and have talent in your team, so you give them the tools they need. There is a whole bunch of variety, and everything that is happening there generates a whole lot of well, different aspects that it's hard to see through them and see the overall picture behind them. All these moving parts all together. I mean, yes, if you have 3 systems in your overall stack, it's easy. But if you have a Kubernetes with a whole bunch of different containers with different origins doing all different kinds of things, the effort and the effort is growing and the visibility is going down. All these systems generate a whole lot of data, and this can be kind of the data that the enterprise is needing for their own business, but it is also like peripheral data, like monitoring data, etc., that you would be using in just particular scenarios. Like, for example, you try to find the root cause, or you just troubleshoot, or you try to learn something. There's whole different kinds of data. The growth of data means the reduction of useful information, unless you really counteract and try to catch this development and turn the data into useful information as you go, or periodically early enough. And of course, what didn't change for the enterprises themselves, but it is a huge challenge in the whole world of IT, it's establishing and still maintaining standards and compliance. I mean, it might sound boring, but you have obligations. You have to do the data privacy aspects the way they are expected to do. All of the systems need to play together well, etc. Everything needs to be provable when you start updating systems a couple of times a day. Everything is in a move, and the ability to prove that something that has been done business-wise came through a regular path is getting harder and harder and harder, unless you really try to mitigate this early. And also standards, of course, as I said, the variety is so high, the standard establishment of standards is just pretty much giving up and just going with the flow. Another aspect is budgeting and also costs, specifically hidden costs. Speaking of budgeting, I mean, when you go after consumption models that are very popular in the whole world of SaaS, consumption-based, volume-based, whatsoever, it is very, very interesting challenge to catch this budgetarily, because you still want to be predictable as a large organization for, let's say, a year or maybe 2. In some cases, it is still 3. And you kind of want to create enough space for growth how do you do that when you continuously change things? The other aspect is the hidden cost is it can be created anywhere. It can be through some unfair indirect licensing of software. It can be in the infrastructure territory. It also is something that economically is known as cost of opportunity or opportunity cost. This is effectively, for those who don't know, that while you are doing something, you're not doing something else. And this something else might be more expensive than the other thing. And you kind of lose the opportunity to do things. Since you might end up keeping your people busy all the time with things they shouldn't be doing except of contributing to the real business value, this cost is amazingly interesting challenge. And of course, the enterprise is a synonym for legacy. I mean, okay, everything that you write today is legacy tomorrow already, but I'm talking about things that you drag around with you for many, many, many years, because you cannot really, now it's Kubernetes, right? But you will put some workloads into this scheduler, but by no means will you rewrite all of your core systems, and you have to deal with integrations and all the different kinds of things that got lost, probably knowledge pieces on the way, and you know, knowledge islands and castles with people. It's all normal in the enterprise, and this is what you inherit, and you need to face this in the modern, specifically in the observability space. I'll have a few hints how to do this. And the interesting aspect is people. I mean, 30 years ago it was totally different. Cameron mentioned the cultural aspects that are very important, and team building is very important. You can only succeed if people take responsibility and accountability for what they're doing. There's no way you can succeed otherwise. But this comes with an additional challenge. It's people, right? People accept, I mean, yes, the monetary aspects are still extremely important. Of course, we need some kind of a living standards. We want to feed a family, etc. But people don't go after the money exclusively anymore. You need cultural aspects. You need a good environment. You need to give them playgrounds to develop into something new, etc., etc. And all of this introduces, of course, additional challenges to the companies that have never worked like that before. So speaking really quickly about the opportunities that are coming up in the enterprise, and then you will see that the link into the real observability aspects is going to become real clear. So if you really want to survive as a company these days, no matter what size, you need to deliver fast and you need to deliver continuously. I mean, it is a fact. And of course, things like approaches like SRE are contributors to this, but there's more. I mean, even dancing around the already pretty well established term continuous delivery, it doesn't mean that everybody is doing this, even if they claim. So it is very important to apply approaches that get you fast from A to B and allow you to verify and probably pivot if you have to. So you don't write in stone for 5 years, right? It is extremely important. The democratization of information is extremely important. I mean, we live in times in the enterprise ITs where a specialization is even more important than it was 20 years ago. So people are contributing with parts of what they can. They work in the team, in the swarm together that all together is responsible for something in this system. And they deliver and fix and etc. All together. But everybody has their own, kind of specialities, right? The more important is to standardize what you show them, what they see when they look into the systems. Any kind of information that you provide, you want to make it democratically available so everybody can access this and everybody has an understanding of what's going on. Not overcomplicating things, not building systems for experts that are just 2 or 3 in the whole company. The whole team needs to have an understanding what's going on. Well, okay, specifically in the modern world, in the world of today, it is of course a given that everybody is going to go more and more and more digital. The price for that is that there's a whole lot of processes that you've been doing manually back in the day that you need to automate or let machines help you. that is an important part, and it's also important for observability as such. So now making link into the observability story itself. First of all, what is not observability from my point of view? Okay, well, yeah, I have this slide, which is just, you can read it up on Wikipedia. I always place it. What does that mean? I mean, effectively, it means that there is a way to look into the system based on what the system is generating as output, and you understand what's going on when you see what it's producing. The interesting part about the observability is that it is effectively primarily manually contributed. So this means that you need to create the framework for observability in order to look into it. And it can be done manually, it can be done automatically, but the point is somebody has to do this job. It doesn't come for free. So what it's not is, it's not the same as monitoring. Monitoring classically is a very, very passive activity. It is kind of, yeah, you get a whole bunch of metrics and then you ingest them somewhere and then you look at the dashboards. This is pretty much the classic approach to monitoring. In the observability space, it's closer to the debugging, effectively. And what you do is you really define what you're interested in, and what you see is what you get. So effectively, what you told the system to observe is what you read afterwards. It's different because it needs your contribution. It needs the contribution from the whole team. No, it's not a toy, definitely. I mean, this thing is real. This is the very last point in the list. It is there, and everybody should be applying this. And as Cameron said, thanks for this, you should be applying this carefully. I have a few hints for larger organizations how to apply this carefully. We're not talking about just a piece of text. So there is different standards and reference implementations such as OpenTelemetry, et cetera, et cetera. We're not talking about a piece of technology that you just drop in and you get everything observable. Observability is a style, it's a lifestyle. It's a way of thinking, it's a way of working. It's same as the guidelines that you provide to your developers to write code and deploy it. It's the same thing. It's inevitable part of your daily work. Speaking of standards, there are so many standards that there is really no standards. I mean, observability is still very early. OpenTelemetry community is doing a great job on shaping where to go, but no means it's mature yet, specifically for the enterprises who want to fix things for like 3-4 years. And it's not only for the new stuff, it's not only buzzword. It gets the point. I'm trying to say that observability is not just a hype. Observability is a necessity. Now, what it really means is that you, as I said, you need to carefully do pieces of the design. You need to make changes to the design of your systems if you have a chance to, in order to make them observable properly. Because if you go after the approach garbage in, garbage out, no matter what you observe, it's not going to make any sense to you. It is a set of best practices. There's a whole lot of, and it's a growing set of best practices that can help people really make the system reasonably observable. It's a whole ecosystem of solutions and tools like ours, for instance. You can really pick many, and the number is also growing. There's niches that are occupied by this and this. There's like, you know, general purpose platforms, also like Instana, and you get the point. The number of tools is growing. The variety is big. It is definitely an enabler, as I said. If you want to deliver fast, you want your systems to be observable, because otherwise you're blind. You don't know what's going on. The competitive advantage point is that, as of now, larger enterprises are sniffing into the observability stream, but they are not really there yet. This means that if you want to help your organization transform into something reasonable, you should be applying this early, as Cameron said, suggested as MVP, something smallish. I have a slide for that with concrete suggestions. Apply this and you will get yourself into a good competitive position with your peers in the market. And you shouldn't miss out on this, because this is really happening. So, speaking of how it can help in a classic organization, enterprise, however you call them, You get the visibility into all parts of the system, and actually the system as such, if you design this carefully, you will have an understanding of the overall system behavior based on the behavior of its parts. You get the real control. I mean, it doesn't matter how you work, but the feel of control is extremely important. Remember, I said that the variety and visibility are challenges in the enterprise. You want to gain control back, and observability is the means to get the control back in the whole chaos of modern technology. There is less potential for human error because you should be highly automating everything. And this is also important in the observability space. Something that you repeatedly do, you should not be repeatedly doing. You should automate it once and leave it alone. Hypothesis testing is extremely important for continuous delivery. Also, fast delivery itself, of course, as I said, is important. And this is the chance that observability gives you, because when you're not blind, when you really see how things have changed between A and B, you can compare what pre-release and post-release, right? And this is what this tool is giving you. The fast technology adoption, of course, because the faster you can move, the more you can see, the higher the chance of adoption of different technologies, because you really, I mean, you're not scared of doing so. So you're really confident with observability. Consistent end-to-end monitoring, of course, because monitoring can be considered some kind of a part of observability, because the aspect of monitoring is happening when you made your systems observable. You want alerts, of course, at some point when you figure out that what you see is making sense to you and it's critical. And of course, if you don't sample too massively, this is a very data aspect. Even with a whole vast of data that is flying by, as I described, you should not make decisions to throw data away prematurely, because who knows? And that is very, very interesting, because observability, in order to be not blind or not colorblinded whatsoever, I mean, all these different kinds of things can happen around observability. Better decide to throw data away later, not prematurely. And now, last but not least, how to start the journey to the observability. As Cameron also said, start with a lighthouse. Establish some small chunk of what you want to do around observability in some space that is friendly, that is moving fast enough and can adjust as they go, and apply it there. Instrumentation is a very important aspect of observability itself, so somebody needs to do this job to make system observable. This is called instrumentation, effectively. You instrument your code, you instrument your system. You should be shooting for maximum automation, because everything that you do by hand, it's relevant, of course, but there is so many things that you should not be caring about making them observable. They should be observable per se, like a framework, like different thought, like different middleware systems, etc., etc. As I said, don't sample prematurely. Quickly move, based on some semantics, move from raw data to information. Abstractions are king. The more diverse is what you look at, the more important it is to abstract. Abstracting services and applications, for example, application is something like payment. It will go through legacy stack, it will go through modern containers, whatsoever, but from the perspective of the business, it's still the same thing. And it is extremely important in the observability space to work with these abstractions, to simplify effectively work. You need to organize people around the same domain and give them the same perspectives. As I said, people should democratically access the information that you're providing to them without overcomplicating. Automation of the feedback and root cause analysis as much as possible. And yes, Cameron was describing that the root cause analysis is very important. And our product, for instance, we invested a lot of effort since the beginning, since we existed, into automating aspects of root cause analysis, giving you sufficient hints what you need to look at if you want to understand and then solve the problem. You should not have 10 observabilities in your space. That's very important. You should have basic standards for everybody. I mean, I'm not saying that they should write everything in stone for everybody. Teams should be independent still, but observability is kind of a overspanning aspect, and it should be governed and controlled centrally, which goes well together with SRE teams, by the way. alerts should be smart. You should not grow your alerts, of course, because I mean, at some point you have so many alerting rules that nobody understands what's going on, and you get thrown out of your bed at 2 a.m. in the morning just because somebody misconfigured something whatsoever. Governance aspect around alerts and simplification and pattern orientation are also extremely important. Uniform view on legacy and modern technology stacks, as I said, abstractions, infrastructure understanding, etc., are aspects that should be taken into configuration. You should be able to migrate from one technology onto the other by still using same services, understanding, same application understanding. Hidden costs, as I described to them, should not be accepted straight. Your observability initiative should be transparent cost-wise, because it can really explode very fast if you start generating this observability data uncontrollably. So speaking of all that, Instana is a system that helps you define and implement and continue the journey that I described just now, exactly like this, as I'm suggesting. You can go check us out for free. It's www.instana.com. We love new customers, we love existing customers, we love technology. And we're still a startup and a challenger to the bigger ones. We're happy to take on that fight because we have so many unique things around how to help you solve problems real fast that you will be totally enjoying this. Thank you very much. This is my presentation.
Wow, so many insights. That was amazing. Thank you, Pavlo. I'm overwhelmed now with information. I'm so happy we can watch this later again. I don't know if you now guys have any questions. You can unmute yourself, or you can just post them in the chat. But I did have some questions for both of you, actually, Cameron and Pavlo. Should SRE and observability be applied in classic environments, or is it a phenomenon useful to modern startups only? Pavlo, maybe you can start.
Yes, I can start. I mean, I think that my whole presentation was built exactly around this. I'm claiming everybody should be applying this, no matter what the size. There is challenges as described, but I think that SRE methodology is the best we can get out of what we know right now. I mean, I'm not claiming that 10 years from now there's not going to be a different set of best practices. I mean, IT is moving forward, but right now this is the best that you can get out of different worlds of classic and new approaches. Cameron?
Cool. So having trouble finding the unmute. I would second that. I mean, not to discredit SRE or anything like that, right? But, you know, as with IT, a lot of things are just a new spin, a different take on an old technology or you know, a not new concept. And I would say that in other businesses and things like that, standards like continual process improvement, you know, CMMI or something like this that some of you might have had experience with before. You might be shrieking right now from bad memories, but these are, you know, known practices, and definitely, you know, SRE shouldn't be constrained to some glitzy startups or some only super in-depth technology. You know, reliability and continual improvement can be used anywhere that you care about the outcomes and performance or reliability of something. So definitely agree.
Cool. There is a question from Ben. Which CSP observability platforms are most threatening? AWS, CloudWatch, Google Cloud Observability, or Azure? Cameron?
And I can like be an icebreaker, and then maybe Pavlo will have an opinion on these. I don't know. I have a hot take. I don't like any of those. I would try running my own, or I would look at one of the other interesting SaaS solutions out there, like Instana, or God forbid I mention another competitor. In the interest of fairness, I don't know, you know, New Relic or something like this as an APM tool. But we have many customers who are using Instana, and it's quite a nice platform. I see it at a couple of really large entities that we work with at CS.
I mean, it's fair. Yes, I mean, we have fair competition. As I said, there is a whole bunch of tools out there, and it's at some point it's more like, dislike, etc. But the interesting aspect of what Cameron said is that what if you have multi-cloud strategy, which is a given for an enterprise that wants to survive? They will never get stuck in one. They just need a backup plan. This is what I'm seeing, and that's where things are getting a little bit dirty, because all of them, well, I mean, they do a good job in order to provide to you the solution for their particular cloud. But at some point you want to break out, and then you have a whole bunch of legacy stuff that they probably are not supporting properly, etc., etc. So it is more interesting to go after a general solution that looks independently at this one, like, you know, at this providers, like ours, or what Cameron mentioned as competitors. I mean, you have sufficiently large pool to pick from.
Okay, one very last question, I think for Pavlo mainly. Do you see monitoring and observability solution should be working together? Will that make sense for better SRE practice?
Totally. As I said, it's different things that are complementary these days. So a classic monitoring would passively look at what is already provided in regards to the data, primarily metrics, maybe some partially logs, etc. And you will build some kind of a set of alerting rules based on this stuff. Now, observability gives you a framework to define what you care about. This also goes into the practice of SRE, where you want to express things that you care about in terms of SLOs. So it is a higher order statement that allows you to say, yeah, okay, this service might be broken, but I will not allow this this service to be broken more often than 3 times a day or something like this. You want to express an objective because this is what your business cares about. I mean, accept the fact that everything is broken, and monitoring, I mean, right now, right, when you look at a reasonably large Kubernetes cluster, I mean, we have this colorization of health of different parts of the system in our 3D map. You see at a fresh map, it's always red and yellow. Everything is somehow broken, right? The question is, do I have to care about that or not? So monitoring will tell you, yes, stuff is broken. Observability will allow you to express what you should care about. And when you bring them all together, it is the solid framework for you to make quality decisions.
Yeah, I would second this. I liked the point you touched on there with like mentioning SLIs and SLOs, and I think there's a good analogy there, like comparison with, SLIs should be less in occurrence and like a smaller sampling, right, of these indicators to tell you your health of your system, your service, versus metrics where you have all the things. And I think what Pavlo was describing there is kind of like a nice analogy to that, where your monitoring can cover all these different multitudes. Do you have a disk full? Do you have some other resource contention like CPU or memory or something like that? Is a web endpoint talking to you, etc. And then observability gives you all these different knobs and metrics and other tools to look inside, peel back the layers and look at different things, whether that be APM or request tracing or whatever it might be. They're definitely complementary tool sets, and you shouldn't have one or the other. Definitely they can work together and give you just more visibility.
Cool. Thank you, guys. I think, unfortunately, this is all the time we have for today. I once again would like to thank you both, Cameron and Pavlo and Instana, for this collaboration. It was really fun, and I hope you guys found this presentation useful. I will say again, we will be sharing the recording of this, so you will be able to see the presentation again. Thank you, and wishing you all a really great day. Thanks, Pavlo and Cameron. See you next time.
Thank you, guys. See you. Bye-bye.
Bye.
Thanks for coming.